Ποιο? Όχι καθόλου. Ναι, γι' αυτό. Αλλά δεν το άνοιξε. Hello there, I'm Thomas Hatsios, German American pilot flying the Boeing 787-900 tonight's flight from Zurich International Airport. We're going to be overflying Zurich, Switzerland, Germany, then coming back to the Zurich International Airport, runway 1449, Ilsloc localizer, landing surround in the cockpit for the pre-takeoff preparation of the quality wings, Boeing 787-900 in Microsoft Flight Simulator X. I'm going to start showing you the cockpit instruments, the displays, and the functions of the Boeing 787. 900 jet aircraft. I'm gonna start with the primary flight display that displays the airspeed indicator. The airspeed selected from the flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected with the autopilot flight director system panel, the vertical rate of climb and descent of the aircraft in tens, hundreds, and thousands of feet per minute, all the stiffness of the trigonometric angles, decrease can climb and descent. The vertical speed indicator. We have also the artificial horizon, the altitude indicator with the pitch ladder decrease and the bank angle decrease. The Lszh localizer. We have the onboard antennas of the Lszh localizer that receive the radio frequencies transmitted from the runways we use for takeoff and for landing, and can display the localizer, the horizontal alignment with the magnetic north pole heading of 136 degrees. For this runway we have runway 14 in Zurich International Airport, Lszh in Switzerland, and also the vertical glide slope. You will see that also. The Lszh localizer crossbus, the flight director crossbus for manual guidance of the aircraft, and the autopilot crossbus for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies in the flight mode and 0 with the autopilot and the auto throttle. Later on vertical navigation modes, we have also the HSI, that displays the horizontal situation indicator, the magnetic heading and track, and also the integrated display of the flight plan we have created. So we have also the navigation display, that displays the GPS position of the aircraft, inertial reference position, the magnetic north pole and geographic north pole and magnetic variation depending on where we are on the world. We have also the terrain map with the airports. You can see where they are located in the earth, so you can use, we have our own airport, the Lszh in Switzerland. You can see the 4-letter ICAO name, the runways we're gonna use for takeoff and for landing, and the taxiways. We have also the navigation aids, the nav aids in the navigation aid, the workstation ADFs and DBs. Also the waypoints which are horizontal and vertical navigation fixes and altitude and airspeed constraints. We're gonna select some waypoints later from the flight management computer. You're gonna see how I'm gonna do that and create a flight plan or a flight path or a route. So you're gonna see a complete flight with the flight management computer, the navigation display, and the autopilot flight director system panel, and the auto throttle of the aircraft. So we have also in the navigation display, you can see the terrain and weather reflections from the weather radar. You can see the red, green, and yellow reflections of the terrain around you. You can see the vertical and horizontal also profile of the aircraft as it flies, and also we have the other aircraft that fly around our own aircraft. We have the transporter, the ADSP and ADC transmitter receiver. that transmits our frequency to other aircraft and the air traffic controller receives from other aircraft. Can this way display. You can calculate with the computer using the radio frequency where the other aircraft is located, the distance from our aircraft in nautical miles, the altitude difference from our aircraft, if it is higher or lower, how many hundreds of thousands of feet. Also whether they climb or descend with respect to our aircraft. Also we can calculate the velocity closing in between our aircraft and the other aircraft, will give us a warning, so you can see the diamond shape of the other aircraft. And if we have incoming collision, will give us the TCAS system, the traffic collision advisory system, a warning in the air or in the ground. We have also other things to see. We have the engine indication, the ACAS that displays whatever the FATEX, the full authority electronic control computers that display the engine information. You will see also that later. So we have the primary flight display here. The navigation display over here, the autopilot flight direction system panel, the flight management computer over here, the mouse pad for the flight management computer, the thrust levers, and the speed brakes. Also the so you will see how I'm gonna use all these things, like things like the speed brakes over here, the flaps and the slots, and also the stabilizer, the horizontal trim stabilizer of the aircraft. So you can see the flight controls here, the control wheel, control column, the yoke of the Boeing 787, the rudder pedals. So I'm having got this side stick here to control the side stick that controls the function of the yoke in this simulation. So I can climb and I can descend the aircraft. Also I can make turns to the right or turns to the left like this, very fast. You can see how responsive. Also the rudder pedals. So we have full flight controls, as you can see. Also the thrust levers over here. We can move forward or aft. We use this thrust control. I hope you like my side stick here. You will see a better view later. I control the thrust and the horizontal trim stabilizer. I can trim the horizontal tail of the aircraft as we fly. So this is full flight controls over here. Our system uses the elevator for climb and descent, the pitch axis, the roll axis, the control wheel, making turns left and right, and the rudder pedals for the yawing axis. So you will see how we're gonna use all these things. So I will start maybe with the primary flight display over here. You can see we have the airspeed indicated, the airspeed tape, the airspeed selected from the autopilot flight director system panel, the radio altitude above the ground level, the altitude tape, the altitude selected from the autopilot flight director system panel, the barometric altitude. Right now we are 1,430 feet above the ground level. You can see the mountains around you, and when you're flying also below you and in front of you. So you can use the horizontal and vertical profile of the navigation display for that. We have the vertical rate of climb and descent of the aircraft in 10,000 feet per minute. Here this needle moves up when we climb and moves down when we descend. We have also the pitch attitude of the aircraft in flight, the attitude indicator with the artificial horizon. So you can see 2.5, 5, 7.5, 10, 12.5, 15, 7.5, 20 for pitch up or pitch down. Also the bank roll of the aircraft, how many degrees you roll. You can see also the flight mode done on 0 with the autopilot on auto throttle, later on vertical navigation mode. So the HSI over here, horizontal situation indicator, the ADFs and GPS. Also we have the range right now over here is 80 nautical miles. The magnetic north pole heading again. So you can see also the barometric pressure we have set here, 29.92 inches of mercury for the barometric altitude. So this displays the barometric altitude here. We set it over here from the barrel set. Inches of mercury of hectopascals, so it's 29.92 inches of mercury right now, 1013 hectopascals. Also minimum barrel flight plan rates, or weather radar, traffic, terrain, accept, cancel, reject some warnings from the aircraft. We have also over here system, CDU info, checklist, communication, navigation display, the displays function of the navigation display in the ACAS and the navigation controller system display. So you can see the autopilot flight director system panel, the indications. We have autopilot, engage, disengage, auto throttle left and right, flight director, LNAV and VNAV, lateral navigation, vertical navigation, flight level change, climb continuous, auto throttle, so the indicated airspeed 200 knots, the heading 360 degrees, the bank angle, vertical rate of climb descent, flight path angle, and the altitude also, hold over here. And we have the word localizer and the approach for auto launch, so you will see how to use the autopilot flight director system panel. So you can see 200 over here, 360 and 10,000 is displayed here in the primary flight display. 200 knots and 10,000 feet right now for the altitude and airspeed constraint over here. Target airspeed and altitude, and also the heading is 360 degrees. So we'll change all these indications later before going to flight. You will see also the overhead panel systems, what we need to do to start the engines before going into flight. So you will see all these things. You will see also as I told you, the engines indications over here. So we have what it displays from the FAREX, the N1, which is the low speed starters, have low pressure compressor tube, and with the turbofan to put the engine, the exhaust gas temperature per engine, and 2, which is the high speed starters, have high pressure compressor tube, and with the turbofan to put the engine, the N2, which is the fuel flow per engine per 1,000 kilograms, 1,000 pounds, solid pressure, oil temperature, quantity, and the vibration of the N2 stage of the engine. We have also the outflow valves, the flaps position, the landing gear over here, external retract, the alternate gear over here. You can see the auto brakes over here. We have also the outflow valves for the cabin pressurization, cabin altitude. We have when we fly at 45,000 feet, the cabin altitude should be like 7 or 8,000 feet, and the rate of climb descent, differential pressure like maximum of 8 psi. Also we have the gross weight for takeoff, thousands of pounds, and total fuel on board, thousands of pounds, fuel temperature. So the flight management computer, we're gonna set it. The thrust levers, you can see from the flight management computer. You can see we have the mouse pad here, so I have my own also mouse pad I can use over here like this. So I can select using this mouse pad in the aircraft, the touch screen. You select over here whatever you like from the flight management computer over here. So we have some modes you can select. You can see we use the index here. We can change the other one: performance, takeoff, approach, annunciate status, identity, position, navigation data, flight plans, load traffic, route, load plan, save flight plan. So we have also the keyboard over here, the alphanumeric, and also we can use the displays here. Again, using the mouse pad, you can select something if we like. So you will see also other things, the flight management computer. You can see We have the thrust levers. When we increase the thrust, you will see the thrust indicated here, displayed on the screen. We have also the flaps and the speed brakes. You can see how many degrees we use the flaps. We can retract like this, how many degrees you like, up or down. So you can bring it all the way up or down. So you will see the flaps position over here. Now it's extending, and you can see the flaps are extending in the outside view of the aircraft, are down. Also the slats, flaps and the speed brakes also. So we'll use position full right now for the flaps position. That increases the surface area of the wings and it allows the aircraft to fly lower airspeed. Also the speed brakes like this. You can see the speed brakes extend and retract. So we have also a couple more things to see. You can see we have the fuel control over here. We have the engines, we have the auto throttle disconnect switch over here, takeoff ground switch over here, thrust reverser, the fuel control for the left and right engine, fuel flow left and right engine. This is fire extinguishers for the left and the right engine, pull out and switch, the right transporter, rudder trim over here. So this radio management panel and the pedestal for the engines. Also you can see the radio communications, navigation radio. You can tune the Lszh, SAT, ground proximity weather radar, transporter, UHF, or high frequencies. So we have also to see a couple more things, the horizontal trim stabilizer, and so also you know the outside view of the aircraft. I will talk to you about the Newton's physics, aeronautical and aerospace engineering, and derive some principles we need to know for flying the aircraft, the Boeing 787-900 or any other aircraft. The Bernoulli theory of fluids, aerodynamics. So we need for the air transport pilot license or the commercial pilot license. So you can see we have the surface area of the wings that holds the weight of the aircraft mainly as we fly, the forward wings. Also you can see the thrust component from the engines, the thrust vectors from the engines that propels the aircraft forward, the jet blast from the engines, propulsion from the exhaust of the cone of the nozzle. So we have also the front fans, the compressors inside the engines, the turbines. So we have also you can see the main aerodynamic chord position. So we have over here is 23% of the Mach. This is where the maximum aerodynamic lift occurs in the forward wings. Also where the stall begins, the airflow becomes detached from the top surface of the wings as we fly, and we need to pay attention. So we will stall the aircraft. We have to monitor inside here in the primary flight display. When you fly the airspeed tape, you won't be below the airspeed. We will see the stall speed displayed with yellow and red indication. So we need to have an airspeed above the stall speed and an altitude, an angle of attack below the angle of stall. So we have also, you can see we have the center of pressure is moving forward enough over here in the top surface of the wings. Also where the main aerodynamic chord is usually the center of gravity located here. So we have the fuel, the left and the right wing, fuel tank, the center tank with fuel on board. We have also here is the vertical axis through the center of gravity is the yawing axis. We use the rudder pedals like this, the aerodynamic effect from the rudder to control the aircraft right or left like this. So this is the yawing axis. Also we have the lateral axis from wingtip to wingtip, which is the pitch axis. We use the elevator like this for climb and descent. We can climb, descend the aircraft. And also we have the longitudinal axis, which is from nose to tail. We have the roll control like this. This is the roll. We can make left and right turns like this using the ailerons, spoilers and flaperons. So these all flight controls you need to know for flying the aircraft. You can see the tail movement over here. Also we have the nose wheel steering in the ground that is also affecting the yawing axis. That's why it's controlled by the rudder pedals in the ground of the tiller. So I'll talk to you about it later, how we control the rudder and the nose wheel steering together. Also you can see the bottom surface of the wings as we fly the aircraft. The bottom surface is more flat, and also we have the flaps extended for takeoff. Also we're gonna have an angle of attack that is gonna be mainly positive in flight. So using the burn material fluids as we take off and accelerate for takeoff, the airflow is moving slower below the wings, which creates a higher pressure below the wings, which pressurizes the wings of the aircraft and the weight up into the air. Also you can see the top surface of the wings is more curved, has higher curvature. When using the burn material fluids again, the airflow is moving much faster above the wings, which creates lower air pressure, which sucks the aircraft wings and weight up into the air. So this is the main components of the aerodynamics we need to know for flying the aircraft. So I will talk to you a little bit more. You can see the elevator axis, climb, descent like this. The elevator moving up and down. The rudder axis and also nose wheel steering, and the roll axis. So you can see all these here. We have the pitch axis, the elevator for climb, descent. The roll axis, left and right turns, and the rudder pedals like this. So this is all flight controls we need to have for controlling the aircraft in flight, as you can see. So I'm gonna show you a couple more things about the flight controls. One more view. I will show you the horizontal trim stabilizer also. That affects the horizontal trimming of the aircraft. And one more view of the aircraft flight controls. So you can see this switch here in the control wheel. You trim the nose of the aircraft. You pitch the nose of the aircraft as you fly up, and you pitch the nose of the aircraft down as you fly. So this is the pitch up nose. This is the pitch down nose as you fly. You can see nose pitch up and nose pitch down because you trim the elevator up or you trim the elevator down, which gives an aerodynamic effect. You can see it says elevator trim, left click down, right click up over here. So this is the elevator trim, left click down, right click up. So right click, you pitch the aircraft nose up as you fly, and this way you pitch the aircraft nose down as you fly. Trim the elevator up or trim the elevator down. You have the head-up display over here, the clutter, and the autopilot disconnect. Also we have the flap speed here. So this is the control wheel, its functions, the rudder pedals also. So it's very easy. You have also, as I told you, the horizontal trim stabilizer. So when you fly, the elevator will be moving up or down by trimming it without using. You don't need to use so much the yoke for the elevator. So it relieves the pressure from that, balance the aircraft in flight. So you have also the alternate. This was the normal. This is the alternate channel. Again, you can see pitch trim up or nose down. Elevator pitch trim up. This way you trim the nose up, and this way you trim the nose down. So this is the alternate channel of the flight control computers. You have also the parking brakes here, as you can see, and we have the stabilizer trim cutoff switch. Also, this is red guarded switch. Open up from normal to cutoff, L2 and R2, left horizontal and right horizontal. This is for all Boeing 737, 747, 757, 767, and 777, and Boeing 787. You open up from normal to cutoff, and this disconnects the automatic trim channel. So you have on the alternate manual and the normal manual over here. If you have a failure, you have the flight control computers over here. You can see we have them set in the auto position, automatic, primary flight control computers automatic position. We have also flight control surfaces over here, data computer, other things. So if we have a hydraulics failure, you can see the primary and the demand, engine drive and electric drive and pumps, all the pressurized the hydraulic fluid, which is also pressurized from the pressure from the engine. It will affect the automatic trim from the autopilot flight director system panel and the auto throttle and the flight management computers and the flight control computers. So you open up this red guarded switch for all Boeing, as I told you, 737, 747, 757, 767, 777, 787 from normal to cutoff. You use the alternate manual trim switch all the time, or the normal over here for pitching up or pitching down the nose of the aircraft as you fly. So you have also here, you can see stabilizer trim position over here, rudder trim, flaps position. So you can see we have 4 degrees right now, nose up in the green band, the stabilizer trim. So this is the main components of the flight controls of the Boeing 787. Also, you also have to use the thrust levers, and so you want more view of the Boeing 787-900 flight control system. How to use the joystick, the Lszh 3D, which is for the Airbus. You can use for the Boeing. So you also have a flight control computers on this aircraft. It has the automatic trim for the horizontal tail. You can use the manual trim. It has the normal, the alternate, and the direct modes of the flight control computers, and its channels for the flight control surfaces. You'll see how you can use them when you fly. So we have this view also, as I'm telling you. You can see the side stick I'm using. You can see also this view. So you can see, you can use this for climbing, for descent. So this for climb, for descent, making turns to the left, making turns to the right, like this. Maybe I have better view of the screen like this. So hope you like my side stick, the Lszh Extreme 3D, as you can see. Same like in the Airbus, you use for the Boeing aircrafts also to control the yoke of the Boeing 787. You can see the side stick deflection is proportional to the yoke deflection. All the flight controls are interconnected. The captain and the first officer move together in flight unless they have a failure. They're not like in the Airbus, you have the side stick priority for either left or right side. So you have also the thrust over here, thrust control. So you can use all the engines like this. Also we have the horizontal trim stabilizer here. you can trim the aircraft in flight. So we have all flight controls together, thrust levers, and also engine function like this. Also, we'll show you one more view, the outside view of the aircraft. Flight controls right now. So you can see, we can use this view also for flight controls. The outside view over here. So you can see seismic deflection proportional to the yoke deflection. Also the outside, you can see the elevator for climb and for descent, the rudder, and the ailerons and the spoilers, left and right wings over here. So this is all the flight controls we need to know for controlling the aircraft in this flight. So I'll show you now the rest of the systems of the Boeing 787. You can see also in the rudder pedals, I forgot to mention, we have the rudder, and also we have the tiller here, which controls the forward nose wheel. As we fly, you can see the forward nose wheel here and the rudder together in the rudder pedals. So the nose wheel deflects 76 degrees left and right deflection. In the ground, it decreases as you increase for takeoff to like 45 knots to 7 degrees deflection. Then you have the rudder aerodynamically effective above 45 knots, it decreases all the way to 70-80 knots to 0 deflection, and you have only the rudder after that, aerodynamically effective after for flying, for takeoff or for landing instead of the nozzle. So this is all you need to know. You have also the top brakes, you press the brakes in the top surface of the rudder pedal. So this is all the flight controls. Now I will show you the flight management computer over here, how to create the flight plan. So we have the flight management computer. We'll input all the data we need for this flight. That includes the takeoff gross weight, the empty weight plus the passenger plus the cargo plus the fuel on board, whether fuel is stored in the left and the right wing. We have 30% in the left wing, 30% in the right wing, and 10% in the center tank. The flight management computer is going to calculate the center of gravity of the aircraft from takeoff as we fly. It burns fuel, the aircraft burns fuel for the engine, so the center of gravity is shifted. It should be recalculated in flight every second automatically from the flight management computer. This also calculates the mean aerodynamic chord position from the center of gravity of the forward wings, the Mach, which is 23%, and also the other things like the angle of attack, like the horizontal trim stabilizer position for takeoff. We have 4.25 degrees. We have 15 degrees of flaps for takeoff. Also, we're gonna select the runway. For takeoff, we have the Zurich International Airport, Lszh in Switzerland, runway 14. So we're gonna have the runway length, the runway slope, the wind direction, the speed, the barometric pressure, the density of the air, the temperature of the air, also the runway conditions, if it decides dry or wet. The flight management computer is gonna calculate the takeoff speed, V1, V rotate, V2 for the flaps 15 degrees, and horizontal stabilizer 4.25 degrees. We're gonna have a pitch attitude of 9 degrees for takeoff, and also we're gonna select the seats, the solderings, the departure waypoints and fixes for the initial climb and departure of the aircraft. We're gonna have the cruise to the cruise level like 35, 36, 37, 28, 29, 30,000 feet above the sea level. We're gonna cross through some waypoints, then we're gonna initiate the descent. We're gonna start descending back to the airport so we will descend back to 7 or 6,000 feet above the sea level. We're gonna have the stars, the other terminal arrival waypoints and fixes. That includes horizontal vertical navigation fixes and altitude and airspeed constraints for the terminal approach and landing, the long final and short final of the aircraft. Also, we're gonna have the Ilsloc localizer the instrument landing system of the airport, tune the radio frequency, that transmits the radio frequency from the antennas of the threshold of the runways and received from the onboard antennas of the aircraft, and displays the localizer, horizontal localizer, gonna align also the aircraft with the magnetic north pole heading of 136 degrees of the runway 14. So gonna be aligned with the horizontal localizer, vertical glide slope. We're gonna have the Lszh localizer crossbars. We're gonna have flaps 25 to 30 degrees for approach and landing on airspeed 150, 160, 170 knots. And also we're gonna have pitch attitude of 9 degrees and the landing gear extended. So you're gonna have see the complete flight from takeoff, climb, cruise, descent, approach and landing in the end part of the video. So stay with me until the end part of the video. You can see the complete flight over here. So I will show you now how to use the flight management computer over here. So you can see we have the mouse pad here, another nice view of the cockpit and the flight management computer. So we have the settings, the modes for the flight management computer over here. So we can use other mode, identity, position, performance, takeoff, approach, annunciate status, navigation, data, flight plans, traffic control. So we have the identities, Boeing 787-900, GNX engines, 1B64. So we have the position, Lszh, use the reference. Over here the reference position, so this we can use to align the coordinates alignment, RSL references and the RS. We have the performance here, 0 fuel weight plus fuel on board, the gross weight, reserve fuel, the cruising altitude we're gonna set later, cost index, fuel freezing temperature in flight, center of gravity in flight. So we're gonna set first the route, Lszh over here in Switzerland. So we have departure arrival over here, copy paste, runway 14 over here, again departure. So we can set either runway for the departure, 10, 14, 16, 28, 32 using the right side, and we can use the seeds, the arrange the departure waypoints and fixes for the departure. So we have runway 14 select, and the seeds we're gonna set Zui to Alpha. So we have the arrivals over here, departure arrival. So we set the arrival page. We can set approaches for approach runway VOM 162834 over here. Also ILS 14, ILS 16, ILS 28, ILS 34, GLS 14, localizer 28, localizer 34. We have also the stars in the left side, the side terminal arrival waypoints and fixes. So we're gonna set ILS 14, trans Amiki over here, a waypoint trans, and the stars is gonna be Negria 1 Alpha. So we have the legs, the route is complete with blue but not yet activated. We have a discontinuity here. So you can see the first waypoint over here from takeoff, the heading of the runway, one waypoint by another, climb to the Zui, also cruise level here, then descent, approach and landing, the start. So we go over here, set 0 fuel weight 322.7 plus fuel on board 33.9. We have gross weight 356.6 thousand pounds, the reserves 5% over here. So we set 5% reserve fuel, the cruising altitude 35,300 feet, and the cost index 100%. So we have the fuel freezing temperature over here also, and now the center of gravity in flight 38%. So at minus 37 degrees the fuel will freeze. So we press this green indication, the execute, it asks to confirm. So it will give us a flight plan that is active now. We activated the flight plan with white and purple. So we have 136 degrees heading, the first waypoint after takeoff to nautical miles, 250 knots airspeed and 1900 We make a left turn, 1 nautical mile, 3 nautical mile, another waypoint, 5 nautical miles, 6 nautical miles, heading 052 Zui, 301 knots, 6000 alpha. We keep climbing, make a turn 071, 26 nautical miles to the Negria from Zui, 301 knots, flight level 22,200. Then we make a right turn, 230 degrees, heading is the Mative, 12 nautical miles after Negria, 320 knots, and we descend 11,800 feet, 258, heading 6 nautical miles, 190, 10,400 is the Amiki. Zui, 9 nautical miles from Amiki, 180, 7,000 alpha, Z8 to 90 degrees, Zurich 701, 6 nautical miles, 180, 6,000 alpha. Descent for approach and landing over here, TRA 290, 10 nautical miles, 180, 5,000 alpha, CI 14 to 35 degrees, 6 nautical miles, 180, 4,000 alpha, Osnem. We make a left turn here for alignment with the runway. This 135 degrees, 5 nautical miles, 136 degrees, 5 nautical miles, 170, 4,000 alpha, runway 14, 8 nautical miles from Osnem. 140 knots, 1430. So we have also takeoff ground, initialize flaps 15 degrees, center of gravity 28.5 degrees, and the takeoff speeds V1, free rotate, and V2. We have 130 and 140 knots for this gross weight and runway. So the legs also, we have other things to see, alternate over here, VNAV, progress, FMC, communication, hold. We can select a waypoint and hold to make turns in flight. Fix, we can set rings over here. Also word localizer, and ILS ADF, we can set either frequency, ILS localizer. So this is the flight plan right now, what we need to do. You will see a couple more things before going into flight. So we have here also the navigation displays, as you can see. If we come closer, you will see the waypoints we're gonna use, the flight plan we have created. So you can see the stars for approach and landing over here, the purple line that connects the flight plan, also the climb over here, some terrain in front of you. You can see this is 20 nautical miles away, so you can see the terrain and the waypoints we have to fly through, also in the SSI. So this is for the navigation of the aircraft. Also you can see sender over here. You can see a better view of the flight plan. The further away we're gonna be flying, make the turns here, approach and landing from takeoff over here. So you can see also the vertical climb and then descent, one waypoint by another, and the altitude, how far above the ground we're gonna be flying. So this is a vertical profile. So we have, again, if you look closer here, you can see the runway we're gonna use for takeoff. We have on the right side the elevation of the terrain also. For this range, 2,700, for instance 1,600. So we look closer and closer, you will see we have the runway here displayed for takeoff, the taxiway in front of us, the other runway, and the terrain, some mountains with yellow, green or red. The terrain elevation right now 2,700 for this distance. So you can see the taxiway in front of us, the one we are already in the ground, and the other runway over here we're gonna use for takeoff, and this runway. So runway 14, the other runway over here is same like you see in the outside view. Also the terrain, what it displays from the GPS system. So this is for the navigation purposes, the navigation displays over here. So you can see the plan again from the other side. You can see how far away we are from the runway. We have the map centering over here, map centering, you can see elevation of terrain, the distance again. If you look further away, you will see more things, more clutter. So this is the flight plan, how far away we're gonna be flying. Also the airports. So looking here, you see we have Germany, France, and the Switzerland down here. So this is all the things we need to know from the flight management computer. Inputs, we have their data computer. Over here displays the pitot static and pitot dynamic, airspeed and altitude, and GPS position, laser gyroscopes, magnetic north pole, all their data you see. Angle of attack as we fly. We have also the engines, the FAREX control. The engines, we have the FAREX. The FAREX are the full authority, the electronic control computers. One is for operating the gearbox, Flught channel redundancy. One channel phase, the other takes over. Controls, monitors, the displays, all the engine data using the ACAS. Also the pressurizer from the left and the right. Engine, we need for cabin pressurization, we can engine ADI, air conditioning ventilation. For the hydraulic fluid tanks or the hydraulic, all the systems I use hydraulic pressure, like the flight controls, landing gear, extended track, thrust reversers, flaps, slats, speed brakes, the elevator, iron spoilers, flaps, and also the parking brakes. Use hydraulic pressurizer from the engines. So we have also the APU. So you see bleeder over here for cabin pressurization. We have also the APU. We're gonna start the APU right now. Over here I will show you how to start the engines, to make an engine auto start. So we have the left and the right engine driving IDC, the great drive generator, left and right, 120 to 100 volts, 430 frequency, primary flight control computers in the auto position over here. Data computer, flight control surfaces. So this is the electric panel. We have also FT towing power, FT door, passenger oxygen, window heat over here, the rammer turbine hydraulics over here. You can see left and right engine driving, hydraulics and electric. So you can turn on and off like this. You see the warnings, what this shows us, and then in the auto position. So we have also the wing and engine ADIs over here. You can see on or auto. We have also over here, you can see the recorders. We have the cargo and APU fire over here. We have the electronic engine control for the engine that controls also the FAREX, the full authority electronic control computers, normal and alternate mode, and the auto start. Like this, you can start the engine. We can dump some fuel in flight to lose weight. If we arm this, select the nozzles and how much fuel to remain. We have the left and the right wing fuel tank, the center tank. The crossfeed valve is off, we turn it on, you can feed either engine with either pump or either tank, and balance also the fuel between the left and the right wing tank. Also we have, as I told you, the FAREX also control. You can see the displays from the engines that I told you, N1, exhaust gas temperature, engine fuel flow, oil pressure, oil temperature, oil quantity, cabin pressurization. Also the FAREX also control as we climb the aircraft, as we fly from takeoff all the way up to like 20, 30, 40,000 feet above the sea level. As we climb higher, the pressure of the air, the density of the air become less than half than that of the sea level, the pressure and the oxygen level. Also as we fly higher, the temperature of the air becomes freezing, like minus 30, minus 40, minus 50, minus 60 degrees below Celsius, degrees below zero. So as we fly higher, the aircraft also flies with an airspeed like rate of 2 or 3 times faster than that of the sea level. So we have a higher intake of airflow from the front fans of the engine. So we have a different fuel mixture request every second, adjusted from the FAREX, the full authority electronic control computers. One is for operating the gearbox, as I told you. Also as we descend back to the sea level from the cruise level, that is like 8, 9 or 10, 11, 12,000 meters above the sea level. So it adjusts again the fuel mixer. Also we fly higher, I told you, is freezing. So at minus 37 degrees the fuel will freeze. We need sometimes to recirculate the fuel from the wing tanks and the center tank into the engine's components to heat up the fuel. So this is also done automatically from the FAREX. Also the oil and the lubricant in flight. So I will show you the last thing now before going to takeoff. So we have the systems display over here. You can see we have the electronic digital format of all the systems I show you. So you can see we have the hydraulics, APU, oxygen, liquid cooling, the electric over here, left and right engine, IGT, 130 to 200 volts, 400 Hz frequency, the volts of the battery, and the average main and APU battery. The APU is running, hydraulics also, left and right engine, electric C1 and C2 with hydraulic fluid goes with system used. Also the hydraulic pressure 5100 psi and the quantity of hydraulic fluid. The fuel on board, the left and the right wing over here. As you can see, 11,000, center tank 10,900, total 33,300. Low high pressure fuel valves open and feed the engines from the center or left and right wing. The crossfeed valve is soft, but we turn it on, can feed either engine with other pump or either tank. Also the APU is fed from the left wing using the DC motor. You can see also minimum fuel temperature here, below which the fuel freezing minus 37 degrees Celsius and the fuel temperature right now, so we recirculate, as I told you, automatically from the fabrics. We have the air from the packs from the pressurized engine compressors and for oxygen for cabin pressurization. Also the doors are closed, the cabin can be pressurized, the gear and nozzle, the pressure of the tires and temperature of the brakes. Also the flight controls, you can see the deflection over here, how far away we deflect. This is the last thing to see, the flight controls deflection over here. As you can see, we can move the tail, the rudder pedals, so everything is working normally. The elevator trim, FS display over here, maintenance, systems and circuit breakers again. So we have also the checklist over here, the last thing before going to start the engine. So you see before start, after takeoff, descent, approach and landing, navigation display again. So we turn off both engines over here. Both engines in the off position. So we turn on also the lights, you can see. Having got a little bit better view. So you see the pressure is decreasing over here. We have the engines off. You see the hydraulics are closing down the speed brakes, the flaps. So perhaps are locked. So you can see the outside view of the aircraft. You can hear the roar from the engines. So we need over here to start the auto start system very quickly. Auto start, and you can see all reconfiguration with amber indication, amber lights over here. So we have pressurizer from the APU right now is running into the engines compressor. As you can see, above 20%. We have only pressurizer right now. We cannot admit the fuel into the engines like this. So we let the fuel flow, both fuel control left and right on. So we have the auto start is initiating, automatic start over here. You can see 31%. You can hear the roar now. We have pressurizer and fuel. So we have 40%, 44, 45, 46, 49, 50. So you see all the yellow indications are decreasing. So gonna be having running engines at 60%. So now we can go for takeoff. So we use flaps for takeoff. Also the autopilot over here, couple of settings. The airspeed here 253, the heading over here 136. You can set the LNAV and the VNAV over here if you like. LNAV, VNAV, you have the flight director on and off like this. Auto throttle left and right, autopilot engage, disengage like this. Also we have the altitude, set vertical speed. We can descend or we can climb like this. Also the altitude level like 25,300. So we initiate the departure now. We take the air traffic control clearance, parking brakes off, and we have the runway open for us for takeoff. So we use the tiller like this for steering. As you can see, we align with the runway heading over here. We have the tiller for alignment. So we set takeoff over here, takeoff power. Over here, full takeoff. So we press the control, the yoke a little bit down for takeoff until 100 knots. We can align with the rudder pedals. We use a little bit left rudder, now right rudder. So we have 100, 180, 120, 130. So we have V1. We rotate over here. Pitch up 9 degrees or less for takeoff. So we have the positive rate of climb. Takeoff, landing gear up over here as we climbing. So you can leave the side stick off, no problem. The aircraft keeps climbing by itself. So you can see we are 1,800, 900, 2,000, 100 above the ground. So this is radio altitude, 2,400 above the ground, 3,900 above the sea. The airspeed 178, 175 knots. We climb with 5,500 feet per minute. The pitch altitude 20 degrees. We have to pitch down a little bit the aircraft as we climb. You can see also the stall speed here, the yellow and red, the wind direction and speed, the terrain. You can see how far above the terrain we are right now. We are like 3,000 feet above the ground, 4,000 feet above the ground. You can see the engine indication, the flight plan also. We have to fly through terrain further away. So we need also to see the outside view of the aircraft now over here. So this is the departure view of the aircraft. You can see the runways just departing from the Zurich airport. Also the Switzerland here. The lakes, beautiful lakes and the Swiss Alps. So we need to make a turn now for alignment with the flight plan. And we have like 15 more minutes for this flight to end, for the video actually to end. So keep climbing. So use a little bit more flaps up right now. Don't need so many flaps. So this is the view of the cockpit just after takeoff over here. Hope you like it. So you can see again the displays here, what we need to know. Air data display, time flight display, navigation display. So we have a beautiful view of the aircraft here as we fly. So we need to fly through the Zurich, the first waypoint over here. Keep climbing, 13,000 feet. So I hope you like this view from the Switzerland, the Swiss Alps. So we're going for the rest of the flight. We will be seeing also a better view later. We need to start turning over here, as you see. Have a beautiful star sign, so we have to cross through this waypoint, the Zui over here. So you can see here the stalls with the yellow and red indication, and to align over here. So we have the Zui is 2.1 nautical miles. Then we have to make the turn here to align with the flight plan and follow the next waypoint over here. Also both sides of the flight controls displays here, the navigation display and the primary flight display. So we make a small turn here, as you can see. So we align over here with the LNAV navigation. We climb to 19,000 feet and we have like 11 more minutes. You can see further away here, the further waypoint we have to reach as we fly the flight plan. So we have 30,000 feet and we need to start the turn. We have the view here, beautiful view. You can see the Germany, my homeland, Bayern Munich over here, the France, the Italy, this side, the Galaxy, the Swiss Alps, and this beautiful lake. So we start the turn now. We're going back to the airport like this. And we have more than 9 minutes for going back to the airport as we turn. So we have the cabin altitude, the warning. So we need to use the pressurization at total position over here, about 30,000 feet. So we turn, we had a cabin altitude warning. So this is good, it's like the original aircraft. It should rectify now the cabin altitude because we set it to the auto. So you can see as we turn over here, turn over the waypoint, you can see the lakes here, the Bayern Munich, the Swiss, the Germany, the France behind us, also the vapors, the frozen vapors. So make us more steep turn. As you can see, we leave hands off from the flight controls, no problem. The aircraft keeps flying itself. So we use a little bit flaps up for this, for increasing the airspeed. So we have 8 more minutes for this flight. We're leveling off, as you can see over here. Increase the airspeed right now. So we're gonna start descending in like a couple of minutes. You can see we are flying through 23,900 feet. We have the chemtrails over here. The frozen vapors as we fly over the lake, the Germany, the Bayern Munich, and this France view. Over here the galaxy, also beautiful galactic view. So this is a beautiful view, the crescent, the moon also, as you can see. So we need to start the descent now for the airport, as you can see. So idle thrust over here, and we initiate the descent. Speed brakes down also to increase the rate of descent. Align with the flight plan here. So this is the descent now, descending back to the airport, in line with the flight plan. And we have 5 more minutes for approach and landing. As you can see, we have the airport in this side as we are descending. A bit more idle thrust for descent. This is a nice review again of the cockpit and the aircraft before approach and landing. As you can see, we can flying the aircraft, no problem. So we're gonna start also the turn now for approach over here. So this is the approach turn over here. And we have 3 more minutes for approach and landing. Keep descending over here. Three more minutes. There's a bit left rudder over here. So line with the runway now, as you can see. So we are very close to the runway. We need a couple more minutes for landing. Add some flaps also as we are approaching. So we use manual flying again, and we have 2 more minutes for approach and landing. So we have some side wind. We need to combat the other side wind. Some wind gusts over here. So side wind here, wind gust, and we have about 1.5 minutes for approach and landing. So we're gonna make it. We need to align with the side wind over here. The wind gusts that make the aircraft lose its heading from the runway. Adding up a little bit more flaps also. Full flaps for landing. A little bit more thrust. Like 60%, 70, 80% sometimes. So we have the wind gusts here, as you can see. Side wind, crosswind component. We need to align with the crosswind sometimes. This makes more difficult the alignment, as you can see. So we have the runway. We have also the ILS localizer over here. The necessary information from the ILS localizer. We are aligned over here, so we're going for landing. A bit more idle thrust. So we're going to be aligned for the touchdown here for the flare. Align with the runway heading. So we're going to be flaring a couple of seconds. So here's the flare for touchdown. Beautiful flare, as you can see. Idle thrust. Body gear down. Nose wheel also. So parking brakes. Thrust reversers. Full thrust reverse over here. So we're slowing down. We are in the runway. And we made a very beautiful landing, as you can see, full manual. So we have the slowdown here. So you see the thrust reverse, and we are fully down. Thrust reversers off. So that was the flight.